in all my years that I've been in hydraulic, I have to say that hydraulic, if it's used well, it does a great job.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, please follow us on Twitter. You can find us there at the NFPA. And while you're there, share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is actually one of the ways that we source topics for our show. If you see an interesting application of fluid power and you'd like to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to the show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. Those ratings really do help more and more of our friends in the industry hear about the show and then join in on these important conversations. On today's show, our guest is Danielle Stratti. Danielle is the North American Sales Manager for Hydraulico, and they are a distributor of hydraulic and pneumatic products and components. And today we invited Danielle into our forum to learn more about the unique role that hydraulics plays in almond harvesting equipment. Danielle, welcome to Fluid Power Forum.
Hi, how are you? Bonjour. Est-ce que ça va bien?
Bonjour. That's about the only French that I know. So thank you for that introduction. We're speaking to you. You're in Montreal, Canada, if I remember right.
Absolutely. And it's the cold weather here.
It is that time of year. It's also cold here in Milwaukee, Wisconsin today. But we're very happy to have you on our show. I'm hoping that you can tell our listeners a little bit more about yourself and your background.
My God, I've been in hydraulic for 42 years. I started by consulting. So we did a little bit of systems, and then we went on to follow courses of hydraulics. And we've been into hydraulics for many, many years, so over 42 years.
Were you formally trained in it at one of the, are you a native Canadian?
Yes, I am. And I was trained also with Dr. Fitch. That's in the institute out in the USA. So Dr. Fitch been quite a good reference. So is Dr. Tessman and Dr. Ong.
And they're all still teaching today?
I would say that they're getting old, right, with time, but their kids are there. So Dr. Tessman's got a kid now, which took over his lab. As far as Dr. Fitch, he's got his son, which is doing extremely well with the filtration. And Dr. On, I kind of lost track with all these years.
Well, it's good to hear that fluid power is a family tradition that gets handed down from generation to generation. Are you getting close to retirement yourself? You said you've been in it for 42 years.
I'm getting close to it, but I still have about 5 to 6 years left.
Okay. And you haven't been with Hydraulico that whole time. What other places have you worked at?
Well, I've worked with quite a bit of places, but the most important one in my life has been Lucas Fluid Power a long time ago. Uh-huh. Then I started a company with the French people called Hydro-le-Duc, which was in France.
Right.
They're still available as far as pumps and motors. And from there, then I started my home company, Hydraulico, with Monsieur Desi, which was a good partner.
And how long ago was that?
We started this venture in 2003, and today we are a $40 million outfit.
That's great. Well, tell us a little bit more about the company, about Hydraulico. I called you guys a distributor. Is that how you define yourselves?
I would say that we define ourselves with a little bit of two ways, because we do manufacture hydraulic cylinders. We do manufacture some of the components like the gerotor motors, power packs, and we also sell some products like gear pumps, piston motors, tanks, and so on,
Yeah, we're finding that. I'm going to assume that you guys also do system integration or power units of some kind.
Oh, we do. We do a lot of big systems. We do some for the aluminum company. We do have a team of engineering. They are now 6 people, so 6 engineers that do industrial systems, and we do have a team for manifold blocks.
Okay. Yep.
We have a team that does all of the big projects too. So it's quite a big team.
Yeah, that's congratulations on that. I mean, our experience is that, quote unquote, distributors are increasingly manufacturers and system builders as well. So it's a lot of that engineering expertise that the marketplace needs to reside inside companies like yours in order to bring the products to market effectively. I'm assuming you found that to be true. You're responding to market needs, I would guess.
Oh, yes, we do. But we do have a great team. We do have some young people. Well, that's a good thing because there's a lot of, we're just hoping to see a lot of young people to get into this kind of hydraulic, right? And young people like my son, like Vincent, are growing inside of the company, and they're learning extremely fast, and they're going to pass us. Eventually, they'll be much better than the old folks.
Well, one of the things I've certainly learned from doing our show here is that, yes, fluid power is actually a young and vibrant industry. There's a lot of young people that are learning about it more so than ever before and moving into careers in this industry. So it's an exciting time, as you said, to be part of it.
It's an exciting time when your son comes into the business. That's exciting.
That must be. Well, congratulations. So
Good.
One of the application areas that I know you've worked on and we want to talk more about on the show today is what I called almond harvesting equipment. Almonds are the little nuts that grow on trees, right? I have that right?
They're actually the good nuts that grows on trees. Yeah.
They're the healthy ones, right? Everybody should be eating more almonds.
I do love them, yes.
So can you tell us, before we get into the specifics of the hydraulics, the solution that we want to talk about, maybe we should help our listeners understand the environment and the machine itself. Can you describe the application, generally speaking, to begin with?
Yeah, for sure. And for all of the people that do want to see one in action, well, they can get on our website. It's hydraulico.com. And they can see one there that is shaking a tree. So this type of machine is a self-contained. So it's got one man that is operating. He's sitting inside of the machine. All of the actions are hydraulic. It is self-propelled with a diesel engine. And that's the operator drives from one tree to another tree, deploys a shaker clamp, and grabs the tree and shakes it.
Mm-hmm.
That's how it works.
And how big are these trees?
The trees, I would say that they're not especially big, but they're quite, I would say the surrounding of the trees is about 5 to 6 inch, to shake. So it's quite a good tree.
Okay, a good sized tree. So it's something that obviously a human being couldn't do by themselves. They need the power.
Oh no, you couldn't shake one by yourself.
Right.
No, that's absolutely impossible.
And the shaking motion is what essentially shakes the nuts loose from the branches and they fall to the ground. Is that concept?
Well, I wouldn't say that they fall down to the ground because nuts can fall onto it's a conveyor. It's catching the frame and then it's dumped into bins, right? If they're dumped on the ground, then they're swept into a row and picked up by another piece of equipment. It's a different piece of equipment.
Okay. Yeah. So what makes hydraulics kind of the right technology for that?
Hydraulic has proven to be the most reliable source for this kind of applications, except for the lights.
Right.
I mean, the machine itself's got lights, right? All functions are hydraulic. The harvester clamps have circuit which has a relief valve, and it can be adjusted according to what the trees will be shaken. So clamp pressure differs from almonds, walnut, pistachios, peaches, or prunes. So it's quite important to make sure that we can adjust this because each tree is kind of different, right? So clamps are also equipped with hollow rubber bumpers, and there's a lubricating system just to protect the trees.
So is it, it's the same piece of equipment that is modifiable for the different trees or different pieces of equipment for the different trees?
Absolutely. The almonds, the walnut, the pistachio, the peaches, and prunes only is an adjustable kind of pressure just to make sure that it doesn't hurt the tree.
Okay. So it's a very versatile piece of equipment then that can be used in a lot of different applications.
Absolutely.
And as you said, it's like all of the functions are hydraulics is used. I'm assuming it's partly the power density that you're getting off of a hydraulic system versus other kinds of technology. You know, it packs a big punch in a small package, which is pretty much what you would need for this, right?
Absolutely. So because it's versatile, because we can adjust it to each tree, it is just a perfect machine to do the job.
Well, we're going to want to talk a little bit more about some of the specific hydraulic components that go into this system, Danielle. But before we do that, we've reached the part in the show where we need to take just a quick break to provide an update to our listeners on some other opportunities in the fluid power industry. All right, we're back from our break. I'm speaking with Danielle Strati of Hydraulico, and he just gave us a good overview of Almond harvesting equipment and the hydraulics that powers the shaking motion that helps harvest the nuts from the tree. And we wanted to dive in a little bit deeper and talk about the specific parts of that hydraulic application, especially if there's anything that's unique about that or updated more recently. What are the most unique parts of the hydraulic system?
On the hydraulic, what makes a good choice about this using just hydraulic is its strength, its speed, its compact packaging, its maintenance, the fact that it's very, very poor maintenance, right? I mean, you don't need to spend a lot of dollars, right?
Right.
So this is why that hydraulic is a lot better than just the mechanic use.
So are we using what we would think of as kind of off-the-shelf pumps, motors, hoses, cylinders for this hydraulic system, or are there more specified parts that are needed?
As far as the pumps, the valves, and everything else, they're quite standard. I think that the most part that needs to be well built is the cylinder.
Okay, tell us a little bit more about that. What makes the cylinder need so specific here?
Well, let's say that if I go back into the history, just the cylinder used in the past, were kind of made using weaker and most prone to wear and breakage of aluminum glands and pistons. Clamp cylinders, rod bushing wells were also a weak point and often broke. So as well as rod tread, shearing at the piston, and cylinder tubes cracking. So these were the things that we saw on all of the machine and the problem is you couldn't even make a season that they'd start to break.
Oh, really? Okay. The cylinder itself would fail, is what you're saying.
Absolutely. This was the most hard part on the system because the rest, the pumps were fine, the valves were fine, everything else was fine, but the cylinders fell and didn't last a season. And when you know that this season is very short and it needs to be done extremely fast, you know that you need an equipment that has to do the season. So at that point, we needed to think about the cylinders to have to be robust due to the high vibrations. They are subject to vibration like it's unbelievable.
Yeah.
If you look at our website, you'll see this thing shaking, and you have to consider that cylinder is moving up and down in very high speed. So it's got to be equipped with very consequent seals, So specific seals must resist to the ice cycling, the heat, the dust ingression, so the potential consequences of using low-grade cylinders are just a failure. So it's costly in downtime, productivity, and it just contaminates the soil with oil.
So you've mentioned some videos on your website. I just want to make a point out to our listeners that we'll be sure to put links to those videos in the show notes to this episode, and we would encourage people to go take a look at that. They really are remarkable machines to see in action, as you're saying. And I guess I'm realizing now as you're talking this through that I'm not an engineer, Danielle, so forgive me, but the shaking motion itself that the hydraulic system is creating, that's actually the cylinder moving, extending and retracting at a very high rate of speed. Am I understanding that right?
Absolutely.
And
that's exactly what you're understanding, and that's exactly what we see.
And that's what's creating the ingress of potential materials and or the stress and wear that a typical standard off-the-shelf cylinder is not going to stand up to, right?
Yes. Absolutely.
So you guys must have a specific solution for how to solve that problem, right?
Well, the first thing that we wanted to know is how much time does a harvest is, right? So
yeah,
a harvest is approximately 45 days. Machines will operate between 18 to 24 hours a day.
Oh my.
7 days a week.
Because the harvesting season is so short, they need to maximize whatever time they can, it sounds like.
Yeah. Plus also, in just many cases, these guys that own these machines will also harvest for other people too. Okay, so it becomes obviously that they're going to do their work and then they're going to go out and do somebody else's work too. So that's been what our customer is doing. So he's harvesting his own fields, but he's harvesting also a bunch of people. Also, all of these harvesters are also used to reduce the fruit in the trees, deemed to have too much and not meeting fruit size requested. So they're doing a lot of job with the same machines, right?
Yeah.
We, hydraulical engineering know-how was there to design the right cylinders for their rugged applications. Cylinders were strengthened by using thicker tubes, avoiding rust, rod bushings, and rear mounting wells, better material for glands, piston, ductile, and for enhanced strength and resistance to high vibration generated by the shakers.
So you had to build a more robust cylinder for this specific application.
But there's some of the people that are going to wonder what kind of stress that we're getting just when we're using this. If I would relate into G-force, I would say that we're getting 30 Gs.
Oh my gosh. Okay. So you don't want to be on the end of that. You want to be safe in the cab. I think that by
saying this, a lot of people are going to understand that it's very rugged, right?
It's probably one of the most rugged applications that hydraulics performs in, it sounds like.
Well, this and mining equipment. So this is why that we'll see that type of cylinders with this type of application. Yes.
Do you have a brand name for these robust cylinders, or what do we call them?
Well, we actually use forged cylinders.
Forged, okay.
Forging is a process of working or forming metal to a shape, right? To a desired shape by impact or pressure from hammers, presses, or either a forging machine.
Uh-huh.
The metal object produced through this process is termed a forging. Forging are best used in high-duty cycle or more rugged applications where a more durable, high-quality hydraulic cylinder is just required.
Right. So did Hydraulico produce this specifically for these applications, or are there other applications that this is also used in?
More, if I think about it, I could say that the construction are using forging, mining, refuse systems, just the waste management, right? So this is the kind of market that we'll see with these type of cylinders.
So there's a wider application. Any really rugged environment is going to benefit from this kind of cylinder. Yes, absolutely.
Cost-wise, well, we do have to say that there's certain quantities that are needed. I would say that if you can actually build 50 pieces, you can actually see a price that's going to cost you 3 times a standard cylinder.
Yeah. You get what you pay for, though. I'm assuming, like you said earlier, if you have a cylinder that isn't going to stand up to the wear and tear of a typical season, it's not doing you any good.
Well, it's very costly, to stop a machine
Yeah.
during harvest. It's very costly. Let's say that the customer was actually in a great need to make sure that he can run his machine during the whole season.
Right.
And now he's been doing it's been 3 seasons and the cylinders are still good.
That's great. Yeah, it's a good testament to the durability that we often hear about when we talk about these systems. But it sounds like it's unique, in terms of this applications like this. That it really is something that needs above and beyond from a hydraulic point of view. It's interesting to me that the hydraulic system is able to produce such vibrational speed and such force that it can destroy its own parts, if that makes any sense, right? That it's got to have very robust pieces of itself. I'm used to seeing hydraulics tear buildings apart, so I know it can't, like bricks and concrete can't stand up to hydraulics, but it's interesting that even hydraulics itself can destroy itself if you're not careful with it. Or am I looking at it the wrong way?
No, it's quite the right way, because if you don't choose the right seals to make that kind of speed right inside of the cylinders, then they're going to wear.
Yeah.
You don't choose the right material, yes, it's going to break. And in all my years that I've been in hydraulic, I have to say that hydraulic, if it's used well, it does a great job.
Absolutely. Yeah. I've often said that a well-built and a well-maintained hydraulic system is one of the most efficient things and effective things on the planet. There's no question. So, but building it well and maintaining it well are very essential to that process.
Oh yeah, absolutely. And we see it every time that we sit with a customer and we look at his application. If they're looking to save some dollars, sometimes it's not the right deal.
Yeah. So I'm curious, Danielle, as we come up on the end of our time together here, if you could look into the future a little bit. Are there needs in this application that aren't being met, that we need to adapt some of this technology? Or what do you think the future trend of this technology would be?
Well, if we look at today, when we buy a car, it does drive by itself. It actually, if you back up and there's a car which is coming, it's going to stop and it won't back up to just have an accident. So I have to say that if I look at this kind of machine in the future, I have to say that we'll have to include some of this type of technology so that it can be self-driven. Mm-hmm. And it can actually work into a field without any humans, so we could save some time. So a lot of the systems today include a lot of electronics, and I do have to say that we have the technology to get there. We often do equipment that don't need to be driven, and that's a good thing, mm-hmm. because driving these things can be very tiring, because you're sitting inside with lots of vibration.
Right.
You're sitting inside for your back. It's not a good thing. So obviously the people that are driving these things really get tired. So to me, the next generation is going to be a self-driven, and it's going to be smart enough just to recognize the trees, adjust itself on pressure, shake it, and do a very good job.
That's interesting. Yeah. I mean, that I've heard that trend in a lot of agricultural settings already. There's a big push towards automated functions and automated drive, if you will, as you just described. And the sensors are certainly in the marketplace to do those kinds of things. It sounds like it has not yet been applied to almond shakers at this point.
No, it was not applied because there's a cost to it, but costs are just coming down, just like cars are starting to be more affordable. If you do look at the electric cars, right? So the technology is getting to be affordable. When I look at a computer, we buy a computer today for very cheap money. Everything is going down in price. And I feel that within a few years, very soon, we'll see all of these machines that are self-driven.
Yeah, you may be right about that. And when either you or maybe your son has the world's first autonomous almond shaker, maybe we'll have you back on the show. We'll learn more about that product as well.
Well, our kids are into these systems. You know, if I look at the young guys that are coming in and they're computer freaks, they're doing a good job, they're learning fast, they're wider open to technology, and I feel that they're going to be doing a lot of good work.
Absolutely. Well said. All right. Well, thank you very much for joining us today, Danielle. I appreciate the expertise and the information about this exciting piece of equipment.
I'm just sorry about my English. I just wish that it was better, but my French is much better.
Well,
Mais merci beaucoup. Ça a été très, très intéressant.
Your English is far better than my French, so we'll call it a draw. So thanks again, and that is going to wrap things up for this episode of Fluid Power Forum. Again, my thanks to Danielle Stratty, who has been my guest on this episode. If you'd like to connect with him, learn more about his company or about their services, the best way you can do that is by his email address, and we'll be sure to include that in the show notes as well. Remember, if you like our podcast, please follow us on Twitter. You can find us there at the NFPA. And please share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We do want to hear from our listeners about what kind of topics we should be addressing on our show. Also, to see the latest fluid power technology and learn from industry experts, please make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be in March of 2023 in Las Vegas, Nevada. For more information, go to ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are ably produced by Maddie Parise, NFPA's Communications Manager, and I'm your host, Eric Lanke, reminding you to join us next time in the forum.